We've got Eric Wittner from Esri and his team all set to demonstrate some of the work that you've been doing on 3D cities. So I will turn it over to Eric.
Thank you. Thanks for having me this morning. That's actually a little bit of a wag the dog. That was my old boss over there. These guys are actually the leads on what they do. I just get to present the good work that they do. So I'm Eric Wittner. I'm the 3D technology evangelist here. So I'm just briefly going to introduce the men over here. This is Brooks Patrick. He's a solutions engineer on our CityEngine team. Nathan Shepard, he is lead of 3D visualization. This is Phil Sanchez. He's editing lead for ArcGIS Pro. And this is Sean Morrish. He's the lead for one of the leads for our 3D city information model. And what we want to do today is introduce you to the procedural technology that Jack was talking about yesterday in his presentation, and show you some of the examples that we're developing. That these procedural rules are very powerful, but they can be kind of complex and challenging to make. So we've been working to build libraries that you can use to use this technology to create renditions of the future. And then we're going to move on from there, and we're going to show you some new and emerging technologies, things that aren't yet released but are going to be coming out in this year. And I've asked them to show these technologies, and I just want you to acknowledge that they're doing this Trapeze Act without a net, so they're doing it on technology that hasn't been released that's in active development. So it can be a little bit challenging at times. And then we're going to talk a little bit at the end. Sean's going to take us through the kind of the unifying force behind it, our data model and our solution for 3D cities, for kind of urban planning, and how we're building that and making that available to you. So last year I talked about Honolulu. That was a project that was near and dear to my heart. Now I want to take you through this project here. This is Redlands. This is the Redlands Mall, which is near and dear to my hate. Back in the, 1960s, someone got a really good idea, which is we had this beautiful old downtown, and they decided to take the middle of it, tear it down, and put a giant mall in it. Absolutely brilliant idea. It bisected our whole downtown. You know, at the time, it probably created a lot of traffic. You're thinking like a developer, right? People will have to walk through my mall to get to the other side. No, people never walk through your mall. Your mall slowly withers and dies. So the question is what do we do with this? And so what we did is we brought this data in. This is actually pictometry buildings. There are a bunch of collada models, representations of the existing condition of Redlands. We brought them into CityEngine, and we actually want to do some redesign of this area here to represent how we could potentially change it to bring kind of new vitality to it. And what's driving that is this. This is a train station. It's a light rail system. Hopefully it will eventually connect us to the Metrolink station in San Bernardino. And what we want to do is use this as an opportunity to kind of connect this rail station back to this mall, create a new development that kind of pulls people out, pulls people to the downtown, and kind of spread them along those two streets. So the first thing we're going to do, right, is go in and rip this thing out. So let's get rid of it. Okay, mall's gone. Feel much better. Applause, yes. And we want to actually start doing some redevelopment on it. So I'm going to turn on, the first thing we did is we brought in the road network, and I'll turn off the imagery so it's a little bit easier to see. This road network defines the area we can build in. These are the street widths, right, and we have these lots or blocks inside of them. And we can use procedural techniques to populate them. So if I flip over and I look down on this first block, I can do is I can turn on the parcels, and actually underneath here are some footprints that we've drawn. And we want to use these footprints and these heights to generate some buildings. So I'm going to reach out, select those features, grab the whole block, and generate them using these procedural rules. So this is a rule set we call the Redlands redevelopment example. These rules are rules that are published, they're free online, and you can use them to create features. And it does all the kind of procedural creation that you would expect it to do. So if we kind of look down and look at this building, we can interactively edit buildings. So I select this, I'm going to move it, right? Bring it out closer to a street. I'm going to change its shape. I'm going to scale it, make it slightly larger. I'm going to change some of the rules that are parametrically generating it. So I'm going to take it from 4 stories to 8, and I'm going to change its exterior from brick to, let's make it cement. Right, so again, very rapidly changing the form of this building. Now this is generated from a footprint. I had to sketch that footprint. Sometimes, though, I want to do creation on a larger scale. So if I look at the second block here, I have a set of parcels. These parcels are actually being subdivided on the block. So if I turn this off and I select the block, right, we can see there's a rule for how I subdivide it, skeleton subdivision, etc. So what I'm going to do is select this area, again, use the rules, the Earthlands redevelopment rules, to generate the 3D. Let's take a look at what we created. Right, so here's that block, and what the rules are automatically subdividing that block into parcels. So if I go ahead and turn off these, grab the block, look at its attributes, let's turn the models back on, and I'm going to change the way it subdivides itself, turn it into an offset subdivision, right? It adapts, the models are regenerated automatically. So very, very rapidly, very easily creating 3D features just by applying a rule that you don't have to write. We've written this for you. So I'm going to select all the content in the city of Redlands, and I'm going to generate the whole 3D city. This is going to take a little bit of a second. You might notice that we're not just creating buildings. We're also creating vegetation, which we'll talk a little bit about more later, and we're also doing streets. Streets are parametric as well, so you can apply rules to them to generate them. This example that we've created in Redlands has greatly improved streets. Probably annoyed Shannon to quite a horrible extent there that the original street rule didn't have bike lanes. So now we have bike lanes, now we have parking. And just to prove these are parametric, you know what, Shannon, I'm going to turn off the bike lanes. No bike lanes for you. Take it back to the way it was. You notice it adds lanes, it fills out the distance. So this is all parametric as well. Now, why do we care about this parametric creation of objects? Well, the powerful thing is what Jack really highlighted is that there's intelligence built into these. So what we have here are these kind of strange colored shapes. This is use type by floor in a building. So I can select this building. Again, if I look at the parameters, there's a parameter called zoning. I can look at the usage in the building. Right now, let's see, grab just one. I don't want to change the whole city, just one building. So it's got one floor of commercial. I'm going to make it have 2 floors of commercial, 1 floor of office space, and I'm just going to make the rest residential. Right, colors change. I can see my use types. Why do I care? The reason you care is because there's actually a whole series of metrics that are being generated off this that you can use to drive your design. So it's actually generating electrical consumption, water consumption, energy consumption for heating, wastewater production, brown and gray water, all off of this use type that's set on these buildings. And these are coefficients that you can build in. And you can actually start procedurally building other features into it. So you notice this has solar panels on it. So it's using those solar panels to calculate how much energy it's generating, subtracting that from its consumption and giving you a use. You could take other technologies, green roofs is another example I'll show a little bit later, but various technologies used in design construction, build them into these procedural rules and have them affect the metrics, and then play with your designs to try and get optimal performance. And the great thing is these metrics, right, when you share this is a web scene. Does everybody know what a web scene is? Raise your hand if you don't know what a web scene is. Okay, a few people. A web scene is just a format that allows us to share 3D on the web in a browser. So this web scene here is of the same extent. All those metrics on this building, right, if I select this building, they're showing up here on the web. So I can actually take my 3D design, share it on the web, and people can actually see the performance metrics there as well. So this is kind of color-coded thematically. It's not just that kind of thematic information. This is runoff. So we're actually calculating the amount of water runoff for these areas. You notice the street, the median is catching more water. The planters on the side are catching more water. So the roads themselves can do these kinds of calculations as well. If I go out down and look at the report for the road, you'll see, right, percentage impermeable surface, total amount of runoff is being calculated on the fly, along with information about construction cost, cut, fill, etc. So you notice these buildings have dark, dark blue roofs. You might be wondering why. They're actually catching a lot of water because, in this case, they're green roofs. So if I turn the textures on, right, you can kind of see the green pattern that we've put on those roofs. So again, we're conditioning the reporting and we're conditioning the thematic mapping based on the design features of the building that we're generating. Now what I've shown here is creating from street center lines, creating buildings from footprints, creating buildings from parcels, but this is actually also an interactive creation tool. So we can go in and create new features. So what I'm going to do is I'm going to go ahead and create a new block. We have this kind of empty area here. Going to go in, start creating a street. It grabs the attributes from the first street, and then it's going to grab the attributes from the second street, which is going to be a little wide here. So now it generated new streets. Turn the models off, right? I can see this block. I'm going to select the block, tell it to generate some parcels on there. There's the parcel, there's the models, and I'm just going to go in, grab a rule that we've already written and drop it on there. Get a simple block, a simple mass. That mass still has square footage and intelligence associated with it, right? And metrics, but I can go ahead and flip the facades on and just very rapidly generate a simple 3D building. So this is one of many example rules we're building in this rule library so that you guys can use procedural technology on your own projects. So what if I wanted to continue this? So if I'm going to zoom out, you'll notice there's kind of a park area here next to these buildings, and I want to populate that park with vegetation and make it attractive. So I'm going to turn it over to Brooks to go ahead and show how we can use one of our new rule sets for vegetation to do that.
All right, thanks, Eric. This is taking you right back into that model of Redlands. This is actually Brookside Avenue, right down the street from here. So not only can we create new designs, but we can recreate the world. And what we did was we were able to take tree points from Redlands, the city GIS database, and replace them with accurate models of trees and flowers even. So what we've been doing is working closely with a partner of ours, Eon Software. They're the guys who are responsible for the vegetation in the Avatar movie. And so what we now have are over 100 different species-specific tree models. And we've gone in and created a database that even has the hardiness zones for each model. So with this, we provide it out to you via a nice project, just like the Redlands examples. And we can actually model vegetation. And what we can do is include these rules that we've made, like the plant loader, into rules like Redlands redevelopment or rules that you might write on your own. So you get this really realistic vegetation. So I'll just do a little example of how this also works with that procedural technology. If I was to turn off the models here, you'll see the start shapes. And what I'll do is just create a small planting area right here in the corner of this park, just by drawing the area where I'd want to distribute plants. And there's no fancy scatter tool here. It's all just built into what CityEngine can already do. It's just a simple rule operation. So now we have that area where we'd want to scatter plants. We can take our rule and just drop it right on that polygon. And you see that there are a number of options that appear in the inspector. We can actually choose to distribute random shrubs on that polygon, even control the density of those shrubs, and I can even add a ground cover, such as soil with small stones. So it's pretty easy to model random shrub placements. We actually have these parameters randomized, so by just hitting the Update Seed button, we can just have different distributions of these plants. And in addition to those parameters, we also have different display options, different representations of those models. So these are the highly rendered models for making nice pictures. We also have fan models, which are actually two transparent images, which really cut down on the polygon size, because you'll see This scene in particular has about 11 million polygons. We also have included analytical models. If there are any landscape architects in here, we learned about this in school, and now we can actually design with these massings of plants. And of course, they also update as you update that random seed. In addition to scattering plants, we can also take existing plant models, and just by copying and pasting, actually move those models in there. And they also have a set of parameters that will allow you to change that tree model, say a yellow poplar. So if I zoom out real quick, we can actually take all those trees for the entire city and select that analytical model. And by doing that, we can then really go in to investigate the total tree canopy coverage of a city, look at how that affects the city's heat island, look at different shadow analysis and view shed analysis in ArcScene, and so forth. So to get to this project, all you would need to do is go to ArcGIS Online and just type in CityEngine vegetation, and that will bring up a lot of different projects. The 3D city vegetation is here, and what we've done is made it so you can download it, load it straight into CityEngine, and get started with these rules. There are a couple web scenes here that will give you an idea of the extent of our library. I've opened one right here, and what we have done is just order them by height, so you can actually reference this if you'd like. We don't have millions of trees, but these are a great start when it comes to symbology and really mapping out your current vegetation and actually designing with it. So again, this is live for you to visit. You can actually just search plant identification by height. In addition to web scenes, I wanted to show you guys some cool stuff. You might have seen the Oculus in the lobby last night. What we're also looking into is how to use game engines in really visualizing these environments and rendering them dynamically. So what we've done is take that same scene and drop it into Unity. So right here, after you build a game in Unity, you get the files and the exe file to run your game. I'll go ahead and execute that. Unity is just one of many game engines. Crytek is another one. Even some game engines, particularly for architecture, like LumenRT or Lumion. They're all really next generation presentation modes, really to the extent of being able to experience your design. So this is just giving you a first person point of view of that same design, and you're actually able to run through it, even mega jump if you'd like to jump from building to building, and of course give the client a new way to experience what a city could be. Right. Thank you. And back to Eric.
Yeah, quick question for you, Brooks.
Yeah, sure.
Is there a vision for actually building reporting into these kind of vegetation objects so we can track cost, track water consumption, et cetera?
Right. Similar to the buildings that outputted those reports, we can pretty much report anything in CityEngine. The area, the object, different volumes, different lengths. So those trees have, their heights. There's a height range, a minimum, maximum grow out that's represented by those analytical models. And with that, you can start to count the trees, start to estimate costs, exactly.
Excellent.
Yeah.
Thank you. What I wanted to do is we've seen an example of actually creating a park or a garden on the ground. I want to take that up higher and actually do that kind of editing in 3D. So I want to turn it over to Phil to show ArcGIS Pro. ArcGIS Pro is our new application. I'll let him talk about it more. Actually show you a little of the kind of editing that you can do building a garden.
All right. Thanks, Eric. So what I like to show is how ArcGIS Pro can be used in a geodesign context to enhance proposed design projects. And in this case, that proposed design is a rooftop garden in downtown Philadelphia, about 200 feet up from street level. I also want to show ArcGIS Pro's new capabilities for viewing data in both 2D and 3D side by side, so that's going to help with this particular workflow, and then highlight some key features for editing, modifying, and placing elements such as this using the Pro app. All right, so let's go ahead and zoom in, get a little bit of a better view of the rooftop garden. So in this case here, we've received a design. It's a 2D plan view. And what we want to do is update the plan and also enhance it and then 3D enable it. So I'm going to go through a few different tasks and show you how you can do this using ArcGIS Pro. So the first thing I need to do is to add some additional features that have been added to the plan. So the first thing we need to do is add a fence to provide a barrier for the perimeter. In this case, it's a glass wall. And what I'll do is I'll activate the Create Features pane, similar to how currently Desktop uses feature templates to create data. Let me go ahead and activate that map. And I'll use our trace tool to simply just trace around the perimeter of this rooftop. And I'll create the first segment. You notice once I create that first segment, you're getting some feedback instantly in that 3D view. I'll keep going and finish up that fence. So there you go. So as you draw, you're getting feedback in that 3D view. And in this case, that particular type of task is more appropriate to draw in a plan view as opposed to 3D. So next thing I want to do here is just to add some additional trees. And I'll choose a different feature template. And let me zoom in. All right, there we go. And as you start creating features, you're seeing them dynamically. So no refresh required. These are just automatically updated in the map. In this case here, we need to add some screen trees. There's some HVAC facility on top of that roof on that side. So now we're done with using that 2D plan view. I'm going to go ahead and close it just so we can get a better view of the rooftop. And so we got some trees now. We have that glass wall. Now the next thing I want to do is what I would call 3D enable, 3D enhance some hardscape elements. The first thing I want to do here is work with the planners layer. So this is some exposed concrete planners. And I'm going to simply select all the features in that layer. Now they're selected, I'll open up the attributes window. So this is what we would call parametric editing. And I'll select all those features, enter a value for the site. There we go. So because this layer is already prepared for extrusion, we can simply add some attribute information to that to provide the height for it. I need to do the same for the corresponding soil in those planners. So same task, slightly different value. All right, I'll clear that. And the next thing I want to do is there are some benches that are associated with those planners. So what I'll do is I'll select those again. In this case here, I'm going to perform an interactive edit. So I go to the Edit tab. Let me zoom in a bit. And I'll click on this Move tool. And what you'll see is some handles that are going to provide the ability to reposition these features. So because we want to move them up vertically, I'll select this green handle and simply just move them right up, just to a seat bench height. And I'll commit that. All right, so this is starting to come together. It's looking a little bit more realistic. The last thing I want to do here is to add a water feature. So go back to my templates pane, select a fountain template. This is slightly different. I'm actually selecting a 3D model. And I'll place it in the lawn area. And as we saw before with that Move tool, I can simply reposition it. And let's get a better angle. And I have a mini toolbar at the bottom. I can simply access some additional reposition tools, such as Rotate. So I'll rotate it to the proper orientation. And commit that. All right. All right, the final thing I want to do here is to turn on some more layers. Of course, there's additional elements in this rooftop garden design. We have some trees, of course, that go along with the planters, some shrubs. We need access for the elevator, shaft, and then some additional elements. So this is starting to really provide some realism to this design. This is something that can help, presenting this to clients or other stakeholders that really want to get a better sense of what this design could look like if approved and if built. So there's how you can perform some small-scale design, geodesign with ArcGIS Pro. And you can simply just zoom to different locations and get a better sense of what that garden could look like. Thanks, Eric.
So, what is ArcGIS Pro?
Well, it's a new desktop application that we're working on currently. It's a 64-bit app. It's multi-threaded. It supports multiple views side by side, as you can see here. Multiple layouts. It's a modern, updated user interface. We're using the ribbon now. So we're really trying to simplify the user experience, still providing a lot of functionality and capabilities that desktop GIS require for a lot of workflows. And it will be available later this year.
Excellent. So this is the beginnings of the unification, where we take scene, globe, map, combine them together into a single application. We have 2D and 3D at the same time. We have 3D layouts, so you can actually make 3D maps, which you referred to briefly in there. And so it's going to not replace the other. There are other products will continue to exist, but this will be a new tool for doing design work in to kind of blend that 2D, 3D world. Okay, so we've seen a lot of example rules built on footprints and parcels and street data. We've seen vegetation built on top of the tree information from a city. And we've seen creating this kind of great garden view within a city. Now we actually want to take this, put it all together, and share it out to the world. And we have some new technology that's being developed in order to support that, kind of above and beyond traditional web scene. I'm going to turn it over to Nathan to talk about what's coming next with that.
Thanks, Eric. So here we are in Philadelphia, and we're looking at it in a web scene. And this is our currently released version, and this is the rooftop garden that doesn't exist yet. You can see it looks much better after we do something with it. So the key point of web scenes is to provide a critical element of any design, and that's sharing it, whether that's to get feedback or whether it's to get other ideas for changing the design. And the web scenes support all of those, so we can turn comments on, and people can look at the design and make comments about whether or not they agree with it. The current release of web scenes is one of its current limitations, if you like, is it can only handle a certain amount of data volume. So it's fine for this use case and many use cases, but as soon as you want to start getting bigger and looking at things further out, then we need an updated version, and that's what we're working on now, where it's more like web maps and all of the content streams in. So this is the view of the rooftop garden from space. So not really a good use case for a global 3D map, but something that is a good use case is climate data. So whether that's storm tracking, or in this case, the path of Hurricane Andrew, we can come down and we can see where it went, and we're thematically showing wind speed and also labels for that wind speed. And now this looks kind of cool, but we can always switch out our layers on the fly and use a different base map that includes things like the names of the islands and the cities that were affected. So it really is services that are connected, and you can just switch it out as you need. And you can always switch back to the other base map. So that's global. Let's fly over to the other side of the world to Switzerland, near Interlaken, and go down to the landscape scale or the regional scale. And when you're at the regional scale, you have different layers that you're interested in. Probably the most important one is the terrain or the elevation surface. And now we can see around Interlaken. It's pretty steep, very nice looking place. And we've got Jungfrau and the Eiger, so there's labeling to help you identify key peaks. And we also can start bringing in some avalanche areas or some features that are helpful. Maybe these people here would be interested in knowing this is a critical avalanche area. They probably already know, but this is a way of sharing. So again, 3D sharing on the web. So we'll just zoom out a little bit, and then we'll go to the next scale. So we've done global, landscape, regional scale, and now we're going to go down to the city scale. And we're going to go to San Francisco. And again, different layers, we're a different scale, different contents required. So we've got some great buildings here from Pictometry and Precision Lightworks. Let us play with their data a lot, so we really appreciate that. And then other important elements at the city scale is streets and street names. And we've got smart street names, and then we can pan around and have other content just sort of flash and come in. So streaming services coming in, and you can see your entire city this way. So city scale. level data. And now we'll go to another city. We'll fly over. I'm just zooming out a little bit because a few people said they felt a bit nauseous when I was a little too close to the ground and flying, to Portland. And we're going to look more at a thematic city. So real-world cities is just one element of how you want to represent your data and share it. It is useful in certain cases, but for a lot of planning and GIS cases, it's one of the least useful ways to represent your city. So I'm going to change my base map because I want a different kind of look and feel to the scene, the web scene at this time. So now I've got some street labels, and you'll notice these trees. These are the same tree models that Brooke showed earlier, and Portland actually has a point feature with the height of the tree and the crown width of the tree. So it's a point feature with two attributes, and from that we can create this representation of it. It's very close to the real world and very useful for planning. So we can turn on the shadows for them, and we can see the shadows adjust. This is in March, and it's also useful for cases where we want to maybe put a proposed building in and see what difference that might make. So in July, that extra shadow from that new dark evil building is pretty minimal. But if we switch to, say, November, you can see that nearby buildings are impacted by it. So this is some visual analytics done on the fly straight away, really fast, just using 3D GIS in general. In this case, we happen to be using the web scene viewer. So web scenes are important for sharing 3D content at all scales, whether it's a single building, an entire city, a region, or a global scale set of information. So I'm going to hand it back to Eric, and he's going to introduce the next element for using consistent data models and workflows to make doing this task easier.
So I just want to highlight this. It might be a little subtle. This is a 3D web scene. It's running in a browser. It has no plugin. We saw a hurricane. We saw regional information interlocking and two cities streaming into a browser, just like that. So large-scale data now without any plugin. I think that's pretty incredible. So again, we've talked about kind of all the things you can do with it, but how do you get there? That's the challenge, is what's the best practices that you can use to get there? And last year we kind of introduced the alpha version of what we were working on, which was at the time called the 3D UIM. Now it's the 3D City Information Model, which is a component of ArcGIS for 3D cities, a larger solution for doing city management, city planning. I want to turn it over to Sean to talk a little bit about that and kind of show you the gateway of how you can get involved and actually use some of this technology.
Thank you very much, Eric. As you know, that the GIS and a lot of modeling is based on use of features which are connected to databases, and the structure of those databases is very important and in how those features are represented thematically in maps. And now, with the advent of 3D cities, and the idea behind 3D City Model is to take the next step from the 2D environment to 3D. And we're leveraging all of the capabilities that we have within Esri, so both desktop, server, all of their maps and apps, and other tools and extensions that will enable users to take their 2D or 3D data, integrate it together into a usable model. So what are the themes that we are concentrating on with this 3D information model? We're concentrating on those issues which are closest and dearest to city planners and to geodesigners: the built environment, the legal environment, and the natural environment. These are pieces which are represented by polygons, points, and lines, and also by 3D attributes in most GIS environments. One of the things to do with it, one of the ways of doing this is to draw together a lot of different formats. We have CityGML, we have the local government data model, which is used quite a lot in the US, and other models which are used across disciplines and also cities and governmental in groups. So the idea is to simplify the creation and use of and analysis of 3D cities. So one of the other reasons for this is, as you saw with Brooks and also some of the tools that will be coming out with Pro, is the use of procedural modeling, not only in CityEngine, but also in a natural GIS environment. So the latest release of ArcGIS has the ability to consume rule packages that have been defined and developed in CityEngine. So they depend on a concurrent and consistent geodatabase model, so that when you apply a rule, that the expected results occur in your model. So these are the types of outputs you will get from using that type of models. And these are the types of attributes that we're working on at the moment in the built environment. So buildings, both the exteriors and interiors, so form and function of the buildings. Also, as Eric showed in the Redlands example, the land use. So if you have a land use feature, you can attribute that and create that in 3D as well. Interiors, from building footprints or building floor plans, and the use of those interiors as well. And also integrating routing and multimodal connections between interiors, exteriors, and other parts of the cities to better use the space within the city. And then for managing cities, there's the issue of installations, street furniture, the many trees that Brooks created that will have to be watered and trimmed. And then also the utilities to deliver the necessary services to all of the users and to the trees and other parts of the city, and take away all the necessary used issues. Then in the legal environment, many users have expressed the frustration with having to read many pages of zoning regulations, and the idea is to be able to condense those zoning regulations into simple, consumable rules, which will allow you to experience and view those regulations in true 3D. So if you have a height restriction, a setback restriction, or a step back restriction for certain areas of a city, or a type of zoning, you want to be able to see how that affects the city. Looking at it in 3D is so much easier than trying to understand the legal written experience of it. And then also the natural environment, because you are designing on top of the natural environment as well. So these are the effects, these are the things that you're going to be affecting, so you want to take those into account. So things like groundwater management, expectant wind range. You don't want to build buildings and then suddenly discover that you have constructed a mini tornado alley in your nice now new development downtown. So how do all of these come together, and how do you express them? So going back to the web scenes that we saw earlier, we've now been able to take that and publish those out. So you can create your models, then take your existing 3D environment. So you may have photogrammetrically correct buildings from pictometry or other providers, or if you have building footprints, you can use the information with regards to the building type, the building height, and other building use to procedurally generate those buildings and get an accurate rendition of that particular part of the city. And then, as you see here, we have the rendition of the city, but we also have these spaces or shapes, and they're not just volumes, but they're actually they represent the planning space and setbacks that the rules and regulations and the zoning regulations for the city have defined. And you can then look at this and go, okay, well, what buildings are outside of the zoning regulations, and then also, well, how accurate is my model? So Using LiDAR, you can accurately represent the heights of the buildings, what they really represent. So these red zones here are the actual point densities above the building's height, so they represent the true heights of those buildings. And then also you can take, another way of looking at it is what is the developmental potential of these areas. So this is, we are zooming out to a redevelopment area, and then using the metrics that are built into the procedural model and the existing development for these areas, we can visually represent the development potential for this area. So these are some of the tools and applications and presentation pieces that we're showing right now and working on in the 3D Cities model, and also with the 3D Cities group. And if you're interested at all, we have a GitHub examples available with both the schema and the examples of the Portland models. And there's also a example on ArcGIS Online. And you can see a number of examples of the rules and models that we have put up there in WebScene.
Okay, well, thank you very much. Please thank the guys for giving this great presentation.